Hey guys, let me welcome you all to another video. So sometimes you are given a question like what we've got here, a transverse wave, and you're asked to calculate certain things like the wave speed or the amplitude or the frequency. I've got you covered. I'm going to do all of that in this video. So let's go through these questions together. So in the question it says the sketch below shows a wave in a medium. So we are given certain information here. You can see the position is 20 millimeters from the rest position, and then we've also got the distance between two consecutive troughs. So they've given us the wavelength. So the first question says, identify the type of waves illustrated above as transverse or longitudinal. Give a reason for your answer. So this is a transverse wave. The reason why we say it's a transverse wave is because if you look at the movement of the particles on the wave, these are the particles of the wave. You can see that the particles themselves move upward and downwards, and the wave itself moves from left to right. So the angle that forms between the particles motion and that of the wave itself is 90 degrees. And if that's the case, then we are dealing with a transverse wave. So in the second question they say define the term amplitude. Now the amplitude is by definition the maximum displacement a particle can have from its rest position. So if you consider the rest position or the equilibrium, the maximum displacement a particle can have from the rest position is called the amplitude, and already we can see that the maximum position or displacement is 20 millimeters. So that's the definition of the amplitude. So 3.3 just wanted us to write down the amplitude of the wave, and we saw already that the amplitude is 20 millimeters. So we can just write that as 20 millimeters. So the next question says we have to give 2 points that are in phase. So when points are in phase, so when we look for points that are in phase, we need to find points on the wave that have corresponding positions. So if you look at S and U, for instance, we can see these points are on the crest of the wave. So these 2 points are in phase. They have to assume corresponding positions on the waveform. And similarly, if you look at S and T, for instance, these 2 points are out of phase because S is at the crest and T is at the trough. They do not assume corresponding positions on the waveform. So the 2 points you can write is S, S, and U, or you can also write T and V. So the next question says, for this wave, write down the magnitude of the wavelength in meters. Now the wavelength by definition is the distance between two consecutive points that are in phase. So if you look at S and V, you can see that these points are consecutive points and they are in phase. Now the distance between 2 points, two consecutive points that are in phase, is called the wavelength. So now they've given you the wavelength as 200 millimeters, but The question says you must write the wavelength in meters. So I'm going to write everything in millimeters on the left side and everything in meters on the right side. So we know that there is 1000 millimeters in 1 meter, and we don't know how many meters is there in, how many meters make 200 millimeters. So what you can do is you can actually form an equation. You can form an equation and you can solve for x. This is the most simplest way to convert from millimeters to meters. So here you can cross multiply. So this gives us 1000 x is equals to 200, and at this point we can just divide by 1000 on both sides. So this and that cancels out. So x should be equals to 0.2 meters. You can just write that. The wavelength represented by lambda is 0.2 meters. This here, by the way, guys, this here is a Greek symbol in the Greek alphabet called lambda. You know, in our alphabet we've got our own set of letters. So in the Greek alphabet, this is one of the letters called lambda, and it represents the wavelength. So let's move on to the next question. It says calculate the wave speed. So to calculate the wave speed, you have to list all the information we were provided and information that we calculated. So already we know that the wavelength is 0.2 meters, and also we've got the amplitude, but the amplitude is something we can't use in the wave equation. You know, the wave equation is equals to wavelength over the period. So the period is still something we don't have. So we still need the period, but we have some information on the graph. Before we find the period, I just want to explain it to you guys quickly. The period is the time taken for a complete wave cycle to pass a fixed point. So if you take this to be a fixed point here, so the time taken for a complete waveform to pass this fixed point is called the period. So already we are given the period to be 1.5 seconds. So we can use that information. Just as for me to reiterate, the period is the time taken for a complete waveform to pass a fixed point. We are actually given the period indirectly, so we can substitute that. So the period is 1.5 seconds. So now we can just substitute that in the formula. So that is 0.2 over 1.5, and this gives us 1.3 recurring meters per second. So I just want to emphasize the importance of the units. So speed is meters per second, but you could also write it as meters per second like that. Thank you guys so much for watching. If you have any doubts, please drop it in the comments, and please subscribe to the channel. A thumbs up would be appreciated. See you guys in the next one.